In this video, we start section 3.4, which is about homogeneous linear systems, which is a special type of linear system. The goal of this section is to study linear systems whose equations all have a constant term of 0. Let's look at definition 3.4.1. What is a homogeneous linear system? Well, a homogeneous linear system of m equations in n variables is a linear system whose m equations all have 0 as their constant term. Each of the linear equations has 0 as its constant term. Now we're interested in the number of solutions that a homogeneous linear system may have. As we saw in the previous section, we can obtain information by comparing the rank of the augmented matrix, the rank of the coefficient matrix, and the number of variables of a linear system. So what does the augmented matrix of a general homogeneous linear system look like? It looks like H-aug here. It looks like any augmented matrix of a linear system, except that the column of constant terms is filled with zeros. So let H-aug be the augmented matrix of a homogeneous linear system, and let H be the coefficient matrix of the same homogeneous linear system. Now, since the constant term of each equation is 0, there cannot be a leading entry to the right of the augmentation bar. There's no way to have a leading entry in the column of constants because every single constant term is 0. Therefore, we must have that the rank of the augmented matrix is equal to the rank of the coefficient matrix. There was no way for that not to be the case for a homogeneous linear system. Therefore, homogeneous linear systems are consistent. That is, they have at least one solution. Now notice also that the 0 vector, that is the vector x1, x2 up to xn equals 0, 0 up to 0. There are n zeros in that vector. Satisfies all equations of a homogeneous linear system and is therefore a solution of any homogeneous linear system. If I plug in 0 for all variables x1, x2 up to xn, in each of these linear equations, I will get 0. Right? That's what it means for the 0 vector to satisfy every equation in the homogeneous linear system. In definition 3.4.2, we give a name to that solution. The solution x1, x2 up to xn equals 0, 0 up to 0 n times is called the trivial solution. Now, since all homogeneous linear systems are consistent and all homogeneous linear systems have the trivial solution as a solution, we have two conclusions in this takeaway. If a homogeneous linear system has a unique solution, then that unique solution is the trivial solution. And second, if a homogeneous linear system has infinitely many solutions, then the trivial solution is part of the solution set.